In this video, we'll generate the phi function and the Gaussian function using Taylor Maclaurin series sum expansion and LINEST polynomial regression. We begin with the array formula, which is array formula of the phi function of these x values from -2 to +2. And here you find the trend line and the trend line equation, which is a polynomial to the 8th degree. And we generate the exponential form of this. But first, we generate the Gaussian function, which is equal to array formula exponent of the x values. And we factor in the 0.5 and square. So this is x squared to the power 2 and the negative 0.5 minus 0.5 times. This is the Gaussian function. We'll divide this with square root of 2 pi later on. But first, we will use the Taylor-Maclaurin series sum to generate the expansion of the Gaussian function. It is the summation of a times x to the power 2n, where n starts from 0 to infinity, and the coefficient a is equal to -1 to the power n over n factorial times 2n. So our n will start from 0 to infinity. We'll try to reach infinity, and 12 is good enough. So we can enter the Taylor-Maclaurin series sum expansion. Array formula, series sum of the x values starting from 0, incremented by, so 2 times 0, 2 times 1, 2 times 2, so incremented by 2. And that's 2n. The coefficient will be this range. Now we can complete the coefficient. So array formula, -1 to the power n, which is these values, divided by, first term is factorial of n, times 2n, 2 times 2 to the power n. Sure. So here you have these values. These values are exactly the same. They are called the Gaussian function dataset. And the Gaussian function dataset is this trend line. And the trend line equations of the Gaussian function dataset are this. And we can calculate the trend lines of this, the polynomials, the regression polynomials coefficients. So this we begin with the power transpose 0 to 8. So our power be x to the 0, x to the 1, x squared, x cubed until x to the 8. We complete the 1 comma x matrix, our formula of the x values raised to the power 0 to 8. Now that we have the 1 comma x matrix, we can now enter the LINEST. LINEST starting with the phi function, comma, that's our data y and data x. And the exponential form, or the gamma, the exponential form of the Gaussian function. So LINEST data y and data x. And the Taylor-Maclaurin series sum, which is RA formula, data y, this is LINEST, so data y and data x. Now that we have calculated the regression coefficients to compare with our trend line. The trend line coefficients, you have 1 on the Gaussian function, and this is zero point 0.5, then 1.123, then 1 times 1.82 or 0.0182, and 1.28 times 10 to the minus 3 on the x to the 8. Now that we have calculated the regression coefficients, we can go back to these two. We factor in square root of 2 pi. So that's divided by square root of 2 times pi. Enter. So these values are now equal. Then we also change this by factoring in square root of 2 pi. So divided by square root of 2 times pi. Now, all three of them are the same. And their regression coefficients are also the same. That means the trend lines are the same. The trend line equations are the same. This completes the use of Taylor-Maclaurin SERIESSUM LINEST Polynomial Regression to generate dataset and trend line and Gaussian functions of the phi and Gaussian functions.